Product rule. If function x equals one function multiplied by another function indicated by the u and the v, then the gradient function f dash x is u times the derivative of this one plus v times the derivative of that one. So it's a pretty simple rule. Now, here's an example. So I'm going to let u equals 2x plus 1 all squared and v equals x plus 3 all cubed. Now, using the chain rule, we'll see that du dx equals 2 comes down, 2x plus 1 to the power 1 times the derivative of this, which is 2. So that becomes 4 outside of 2x plus 1. This one, dv dx equals 3 comes down, x plus 3, take 1 off 2. The derivative of this one is 1, so we don't really need to put the 1 there, so it's just 3 times x plus 3 all squared. Now, applying this rule, we can see that f dash x is equal to u times the v dx, so it's this one times this one. I might just rearrange that and put that one in front of it because it doesn't matter which order you multiply. So it's 3x plus 3 all squared times 2x plus 1 all squared plus, same thing goes with this one, so it's v du dx, so I'll write 4 2x plus 1 times this one x plus 3 all cubed. Now it's pretty messy at that stage, so we need to take out some common factors here. So the highest common factor of this one is going to be x plus 3 all squared. So it's x plus 3 all squared. And this one is 2x plus 1, highest common factor of those two. And that leaves me with 3 outside of 2x plus 1, because 2x plus 1 times 2x plus 1 is 2x plus 1 all squared, plus 4 outside of, and this one's, of course, we've taken out the x plus 3 all squared, it's just going to be x plus 3. Just checking that, because when we multiply that times that, there's a cube, and that comes in, multiplies that one. Just make sure you check that at the end, so you don't take the wrong thing out. And that becomes x plus 3 all squared times 2x plus 1, and this becomes 3 times 2x is 6x plus 3 plus 4x plus 4 times 3 is 12, and that all becomes x plus 3 all squared, 2x plus 1, and this becomes 10x plus 15. And it would be nice to take out the common factor here, so and that's 5, so 5 comes out, x plus 3 all squared, 2x plus 1, and taking the 5 out becomes 2x plus 3. In this second example, we've got a square root function. So we'll break it up. We've got this one multiplied by that one. So u equals x and v equals x plus 1 in index notation. So du dx is simply 1, and dv dx using the chain rule is a half outside of x plus 1. It becomes minus a half, and the derivative of this is just going to be 1. So we've got all our relationships. So now we see that f dash x is equal to this one times this one. So it's going to be x times 1/2 of x plus 1 to the minus a half, plus this one times this one, x plus 1 to the power of half. Now that's not wrong, but it's pretty ugly, isn't it? So what we'll do is we'll rewrite this as x over 2 root x plus 1 plus the square root of x plus 1. And putting it all over a common denominator of 2 root x plus 1, this stays as x. We have to multiply that times that, and that will cancel out the square root sign, and we'll have plus 2 outside of x plus 1. And that becomes, remove the brackets and collect like terms, 3x plus 2 all over 2 root x plus 1, which is a lot nicer.